Hello, folks. Can you hear me? Yep. Is that coming through okay? Excellent. Oh, yeah. Oh, excellent. And I've got a pointer as well. Isn't that nice? So, where are we? Hello, I'm Gwen Dawes. I come from the Research Computing Services inside the University Information Services at the University of Cambridge. It's a mouthful, I know. Who are we? So, what do? We look after Cambridge. It's about 60-odd departments, about 4,000 users. But we also have a lot of users that come from outside of Cambridge. So our storage environment is quite diverse. We have a lot of different people from different places, which means we have lots of different demands. We have Iris, EPSRC Tier 2. We have this upcoming AI research resource. We have some Dirac. We have UKEA. So we have all kinds of users from all over the place. And that means that our storage demands are all over the place. They can be quite varied, which is a bit of fun. A little bit more history, sort of background. So this is, as I said, Research Computing Services. Originally started in 2005, 2006. So it was created as High Performance Computing Services. And as Research Computing Services, we have quite a long history of Lustre. We started in 2007 with Lustre 1.6. And that gradually increased in size and numbers up to today. And my personal history is I started Lustre administration about 8 years ago in 2015. My first one was Lustre 2.4 cluster, or a little. I did an amusing in-place upgrade to 2.8. I remember coming to my first lads and saying, I've just an update to 2.8. And the response I got back was, what? 2.8 now? Then did a migration to 2.10, then upgraded that to 2.12, and then did a migration to 2.15 as well. So I've got plenty of experience with doing bits and pieces with Lustre. Yeah. So enough about me, enough about stuff. Let's talk about Lustre. Rich had a really nice slide earlier on, and he said, "Here be dragons." I really like that. Had I not given it the name past, present, and future, I would have used something like Lustre, let's explore these dragons together, because Lustre, as you know, is very powerful, very strong, but it does occasionally like to bite your head off. So let's go and explore this together. Incidentally, anyone in the audience, is there anyone that's a Lustre administrator that's here? 1, 2, 3. Can anyone else also speak for having Lustre bite your head off? Yeah, once. There we go. Very good. Oh, there we are. So, past. What I'm going to tell you about is a lot of stuff that's actually all in the Lustre manual as well. So it's kind of approachable from a beginner's perspective. What actually do we need for building Lustre? So we need 3 items. We need an MGS, we need an MDT for our metadata, and we need OSTs. Typically, looks like my rendering has failed. That's going to get fun in a second, I tell you what. Typically, you store your metadata target and your MGS on some storage device that is then distributed amongst a pair of servers. So typically, if you're a very basic environment, you have one of these guys as the active, and the other one is your passive. And this allows you to have, whenever a failure happens, a failover between the 2 sites. So you typically use something like Pacemaker to coordinate the 2 servers to make sure that everything stays up, even if something manages to eat itself. And that's the same case for OSTs. So you would typically have 2 different servers that are having access to the same block devices, but each one has one active and one passive, but typically for 2 different blocks. So we have a set of OSTs on one OSS and a set of OSTs on the other OSS, but if this one dies for some reason, then these OSTs can then get mounted on the other OSS, and we can continue perfectly fine, even if one of our servers is completely down. Great. Good. Excellent. Now, this works fine. You can keep adding more OSTs to OSSs in this format and make a file system bigger and bigger and bigger and bigger and bigger. But there is certainly a point where it becomes too big. And back in the day, you have an interesting problem of having, you need an MDT, so you get one MDT. So this is an issue with earlier versions of Lustre. If we want to continue making it bigger, you kind of run into a problem where the metadata starts to become a bit of a bottleneck. So how can we make it even bigger? We need more storage. Well, one solution is that, oh goodness me, you'll have to bear with me. What's actually supposed to be is there's supposed to be my MDT-MDS pair up here. So what you can do is you can reuse your MDT-MDS configuration and add another MDT onto the side of your already existing MDSs. And instead of having all of your OSSs in one file system, you can create a second file system using that new MDT. And you can actually you can keep doing this, actually. You can keep adding more and more of these file systems and eventually end up with one server, one MDT setup, one MDT pair that has one MDS pair that has multiple MDTs that are operating on each side with one MGS running all of these file systems. And you can actually it's completely valid in the manual. You can completely do this. It's perfectly fine. But as soon as you have a failure in any of this system, if you have one OSS pair that goes down, what's going to happen is that any of the locks that have been handled on that file system are going to be on the associated MDT, which means that eventually that's going to mean that MDT is going to have a problem, which means that all of the MDTs are going to have a problem because everything is interconnected. So you're going to end up with this cascading failure of systems. And it can certainly bite your head off when it goes wrong, can't it? Not just that. How can you upgrade a file system that's this interconnected? It's a solution, but I definitely wouldn't recommend it. And also, what can we do about backups? Is there a way to back this up? Ooh, I don't think so. So, let's go to where we've gone. We've learned from our lessons. We've seen the mistakes. We've seen how things can go. Let's see what we can do about finding a better solution for this. Okay. Oh, goodness me, my rendering. Gareth, you've left me with some terrible slides. Anyway, so how can we fix this? Well, okay, instead of having one MGS MDT set for all of our file systems, why don't we make sure that we have one new MGS, MDT, MDS setup per file system? This allows us to distribute our workload. It's a little bit more expensive, but it means we can distribute our work amongst multiple servers. Of course, later versions of Lustre also have DNE, distributed namespace, which allows us to actually use both of our servers as an operational pair. So we can spread our metadata out of our directories between different MDTs, and that allows us to actually spread out the server load between the two different targets, between the two different servers, and also spread out the actual I/O load to the two different targets as well. This is actually was one of the biggest bottlenecks that I saw back in the sort of 2.4.2.6-ish days. Once we actually had DNE version 2, this made a significant difference to the performance I was seeing. So this helps quite a bit. One of the other tricks that Matt actually set up, which is an excellent move, is setting up using LVM. So using LVM allows you to actually quiesce the file system, and allows you to actually copy the entire metadata off. Of course, if you lose the metadata for a Lustre file system, you lose the file system. You can survive having parts of the OSTs die, but if you lose the MDTs, that's it, game over. So having the ability to actually back up these file systems, back up the MDTs, very beneficial, very, very powerful thing. Another trick that I found out the other week is that by using LVM, you can actually then migrate the targets live to other block devices on the backend. So if you're trying to migrate components around, so you've got elements that are running out of support, and you need to do things like this, you can actually have time to be able to migrate them whilst keeping everything live, which is very cool. Where are we? Oh, yes. So it was covered a little tiny bit by Rich earlier on, but we're also using node maps. Does anyone not know what node maps are? Is this familiar to everybody? Looks pretty uniform. Everyone knows what I'm very much preaching to the crowd, aren't I? So, as you probably know then, node maps allows us to control access to the file system. It means that we can make sure that clients that we expect to mount can mount, the clients that we don't expect to mount can't mount, and we can also control things like UID 0 management. So we can make sure that we don't allow nodes that are not supposed to have root access to be able to modify our file system. This is really powerful. That means we can separate our administration tasks away from our users so that our users can't end up messing up with the rest of our file system, just in case there's some extra exploits that users can do. It can get messy in times. One of the other things that we're currently looking at as well is trying to ingest all of our Lustre estate into OpenStack. I presume you're familiar with OpenStack. OpenStack is a high-level administration tool for virtual machines, but also physical machines if you use the ironic endpoint. This allows us to actually have physical boxes that look like virtual machines and are administrable the same way as our virtual machines. The advantage we have there is that actually that means that our dev environment can absolutely match our production. It means that it's very easy for us to build software images. It's very easy to then deploy them because they can just operate as essentially just operating system blobs. This means that we can test them out. We can put them into a virtual environments. We can then, if we have we can chain the builds so we know that we can actually verify that everything's working correctly. And yeah, it dramatically reduces the amount of variability that you can get into a file system. So this is actually helping us progress quite nicely, as I was saying, actually, yes. So we can actually do our standard kind of DevOps-y build chain, but for a Lustre environment as well. So we can then have a test environment and check out whether or not some bug fix actually fixes the problem in a way that makes sense. And then once it actually works, we can slowly start deploying that into production, server by server, one by one, but also just essentially swap them over in place. There is a bit of a caveat. As pointed out, there are certainly some dragons about the place. OpenStack, if you've ever played with that, hands up anyone who has played with OpenStack in any significant amount? Oh, that's only a few. So OpenStack, when you create a new machine, especially when it's coming in from Ironic, it likes to go through what is known as a cleaning step. Cleaning is good. That means that the node is in a known good state. It doesn't have an operating system, but it also likes to delete everything on that machine, which also includes all of the user data, which is a bit of a worry if you have petabytes of user data hanging about on a machine that's being played around with OpenStack. So if you are going to do this, then please be careful with it. I've actually made some alterations to the cleaner image inside our environment to make sure that it doesn't do this by mistake. I've made it so that we have three separate fail-safes. The nodes are locked. All of the nodes don't have access to the network that's specific to the cleaner image. So you can't accidentally start a cleaning image. If you do accidentally delete something, and then it won't even be able to have the cleaner image deployed to it because there's a separated VLAN for doing that. And then even if somehow you manage to have this mess up, then the cleaner image also has had MP3 SAS, which is the kernel driver used for accessing remote block storage, as in our storage that is shared between our servers. We have specifically blacklisted that to make sure that if it does delete out all the block devices it can see, it can't see the remote block devices, so it won't delete that data. So that should, fingers crossed, prevent any kind of accidental mistakes. But you never know. There's always, it is after all a powerful thing. Ooh. Oh yeah. Oh, what's this slide doing here? Oh, I guess I was going to talk about this one. So as pointed out with OpenStack, this allows us to actually do some things by literally just failing over to one leg. The advantages that we have with Lustre is that you can fail over to one leg. You can take all of your services, put them onto one server, take the other server completely out of service, upgrade that one, and then essentially fail up to that new server. If it doesn't work, then you can immediately fail back down again, assuming that there's no significant changes to the underlying block devices in the process of doing so. Once you've done that and you're happy with it, then you can take the whole thing back out and fail it up again, so that you then actually go to an updated version. It's kind of neat. And with OpenStack in the chain, it's just a matter of change the image and you're done, right? So this is where we are today. Where do we want to go in the future? We have a bit of a problem. Flash. So Lustre is very good when there is distributed block devices. As I pointed out through this presentation, a lot of administration tasks for Lustre and a lot of uptime tasks for Lustre work really well if you have the same block device presented on multiple servers. But a lot of Flash that is available on the market is singly ported. And that's actually kind of a problem, because as soon as you turn the server off, you lose access to the block device. There's nothing else that can get access to it. The other issue, of course, is that hardware RAID is not great for this kind of stuff. That's kind of pushed everything towards replication. And of course, with replication, with a still quite expensive technology, it's going to get expensive fast for the storage. So it's not a good combination. This is something that really needs to get hunted out. So on that task, I've been asked to design a burst buffer file system. That burst buffer file system is designed to be as fast as possible, have as much capacity as possible, but has no resilience. Okay, all right. The other one it needs to have is a very good visible uptime. So the file system needs to be available in case of failure somewhere, but it might fail somewhere. And as pointed out, with a combination of not having the ability to separate the block devices from the servers, if there's a failure in Lustre on a singly ported device, and I have a failure on a server somewhere, it's going to knock out a chunk of storage. So how do I design around these constraints to be able to make a file system that looks like it's going to stay up? Well, I racked my brains for a while, came up with something that looks a little bit like this. Oh, crikey. I've got some really mangled slides here. Terribly sorry. So, what do you actually need for Lustre? Let's go back to the beginning. What do you actually need for Lustre? What you need is you need a management device, a management target, and you need a root of the file system. In this case, at the moment, the root is statically assigned to MDT0000. So we actually need to replicate those. That's the things that we do need to replicate. But in reality, do we actually need the metadata to be replicated? Do we need that? What happens if we instead had the metadata for each one of our OSTs with the OST itself? In fact, these guys are a pool of OSTs on each server, and maybe if we put all of one user's stuff in one place, then if we lose a server out of the file system, then we'd only affect the one user that's on that file system, and everyone else is perfectly fine. So this is the thinking pattern that I've had for looking at this guy. If we have a single server, any part of this server becomes non-redundant. So if we have some element of this die, some storage, network, hardware, operating system, kernel decides that it wants to blow its own brains out, as Lustre likes to do every so often, then this server goes offline. Those users get affected, but the file system stays up. So we have essentially a server redundant structure. And this also allows us, in theory, to be able to do in-place upgrades by essentially migrating the file systems off with LFS migrate, then doing a replacement, bring this server down, put a new version in, and gradually bringing it back into service whilst then migrating everything back in on a sequential basis. The other thing that's coming up in the future is we have another problem. This is a very nice slide taken from 2017 from Matt's presentation back then. He presented that we are working on doing tape backups from a Lustre file system using HSM, and it uses this thing called Intel Lima. Unfortunately, Intel Lima hasn't been updated since about 2017. That's a little bit long, and we kind of need that. So it is a bit unfortunate, but we're going to have to move away from using Lustre for our tape libraries because we just don't, we can't work with this. It hasn't been updated. We don't have the support for this, which is a real pain, but this is the way that technology goes every so often. What else? We are looking at more trusted research environments. We see that there is a demand for this coming up very strongly in the future. As Rich was pointing out, there is a way to separate nodes out by using node maps, so you can have separate mount points, you can have separate visibilities, but we need full isolation as well. So we see that we need individual networks, at least from what I've read in ISO 27001, you can't have one client able to see the network traffic of another client. So we need isolation in that way. And we need an audit trail. And at the moment, those are not so easy to do. We're currently looking at how can we do that audit trail? What are the changelog things can we do for this kind of thing? How can we do the isolation? Apparently, there's this thing called P keys in InfiniBand. Maybe that's the solution. Haven't tried it, but it's possible. So, where do we go from here? We can't ignore this need for flash. That's definitely a significant factor. And there's definitely this strong demand for what are we going to do about trusted research environments? How do we go forwards for that? And how can we build Lustre in a way that is compatible with our client demands? So, thank you. Any questions?
Thank you, Gwen. Thank you for surviving the formatting challenges. We're going to take some of those Lustre dragons and feed Gareth to them later. Right. So, yeah, are there any questions from the floor? Do we have somebody with a microphone? It's supposed to be Gareth, who's just been fighting for dragon. He's just back now. Yeah. Sorry. Go up. To keep him running around.
Have you thought about the RDB? Have you thought about the RDB?
Well, actually, so good thing you asked that. This is actually DRDB here. But the problem is DRDB is not very good for performance. And one of the criteria for this was it has to be performant. So I'm using DRDB to store the non-performant root of the file system, but I'm expecting most of our users to actually be using subfolders, and so we can make that performant as well as distributed as best we can.
So what are each of those purple blocks?
I'm sorry?
What are the purple blocks?
Oh, sorry, the purple ones are the MDTs, and the orange ones are the OSTs. So I'm mixing the MDTs and the OSTs service on the same servers.
And the MDT on the server will only hand out blocks from the OSTs. The idea is to only hand out blocks from the same OST.
Yes, yeah, because then I actually have a very nice slide about this one. So let's say we have a job A. So we have our clients here. These clients, they have GPUs on them. They run on our GPU cluster, and each job will request a certain number of GPUs. So job A here has only requested one GPU. As such, it only has access to one device's worth of network. So in order to make sure that it has as much storage as it needs, there's no point in giving it more than one server's worth of bandwidth. If I gave A 2 servers worth, it wouldn't be able to consume it. There's only this much worth of networking on the machine that is servicing job A. So in essence, yes, the intention is to use pools and striping to provide only the networking, only the storage capacity is what is needed by the client.
Yeah, super.
So very nice presentation. For your burst buffer / no dual ported NVMe problem, have you thought about using NVMe over Fabric and building out a storage fabric that way?
That's what I was thinking about.
So I've had a couple projects do that, and it's kind of an interesting way to go forward.
I have contemplated it, but then you run into the problem of you'd have to do, unless you wanted to do replication, you'd be running into like software RAID?
Software RAID from one of your sponsors, actually.
Yeah.
I don't work for them, but I've seen some Zinner and some other things where they've done software RAID, and of course, you still don't get peak performance of a single NVMe drive, but it's pretty darn good. And when you start building out sufficiently large Lustre, file systems, you do spend a lot on this interconnect fabric, but it can also be repurposed for other, storage activity, especially if you have some. Depends what your Ethernet fabric is and how you deal with congestion. But it's just something I thought maybe you should consider.
Appreciated.
Okay. Oh, we have lots of questions. I had one all lined up, but I might get to ask it. You're safe, because that was particularly nasty. No, it wasn't.
I was just interested if you could say a bit more how you're using Node Map. I was interested what you're using it for, how you're using that in the environment.
In our current production environment, not as much as we ought to, honestly. Primarily, it's used for essentially making sure that our nodes are not actually, we know which nodes are mounting from where. Let me just rack my brains on that one. Apart from admin and trusted, and making sure that we have valid nodes and invalid nodes, there's not too much more going on in production, unless you can think of something that I've missed.
Are you thinking of other things?
Well, as pointed out, sorry, Matt asked, are we thinking of using other things? Obviously, it is a very nice way of doing isolation for clients as well. So if we have a set that is doing TRE work, we can only present a specific chunk of Lustre that way. And that gives us a level of isolation, but not enough isolation. We need to have full isolation in the network, and we need to have auditing. And once we've got those, then we're kind of going in that TRE direction.
Cool. I think we've just time for one last question.
Okay, so this may fit in the history bit, but it's talking about the burst buffers. So I remember looking at burst buffers for Lustre in the 2010s. I was just doing a bit of Googling, and ORNL did some work using Memcache to work on the burst buffers. Have you looked at historical things, or is there something in the new Lustre architecture that would prevent you doing that?
I actually haven't. I appreciate that. I hadn't considered looking at Memcached for this kind of thing. Huh.
It was worth coming.
No, absolutely. Thank you. No, I will definitely do a review. Would love to. Thank you.
Okay, well, thank you once again, Gwen. I think the number of questions says well-received talk.